So today we're going to be doing an extension lesson. So in today's lesson, we're going to just be talking about how do we write equations for quadratics. Now we learned three different forms. We learned vertex form, we learned intercept form, and we learned standard form. So we're going to be practicing how do we actually write equations. So in yesterday's lesson, in 8.6, when you were identifying the type, we didn't have you write the equation. So if we take a look at a problem from yesterday's lesson, like number 2, we knew it was quadratic, but we weren't really sure how to write this equation. So we'll be kind of taking a look at problems like that today. So on the first set, on 1 through 3, we're going to be looking at how do we write in vertex form. So let's just quick write down what vertex form was so that we just have a visual reference here. It's the one that has the H and the K in it. So we've got our vertex form. Now in vertex form, you are going to need to replace the A, the H, and the K. This is technically a Y. So if you want to write Y equals, we can do that. And then the X. So we're going to leave the Y and the X just like you did when you did slope-intercept. When you did slope-intercept, Y equals mx plus b, your answers turned out to be things like Y equals 2x plus 1. Do you see how the X and the Y were still present? We just had to replace the M and the B. We're going to essentially do the same thing here, only now we have quadratics. So let's take a look at number 1. Number 1 is giving us the vertex, and it's telling us it passes through this point. So again, I'm not going to draw a perfect picture here, but if we were to do a rough sketch, if we were to go over to 8 and up to 1, that would be our vertex. Now this point, say 10, 13, that's just the side of the parabola. So that must mean it looks something like this, which is helpful because I know it opens up, but I really don't know what the A value is. Is this wider than normal, or is this stretched? Is it more narrow, or is there no change at all? I really don't know. So we are going to need to calculate what is that weird A value. Okay, so the first thing we're going to do is we're going to plug in this vertex for H and for K. So if I just take my equation and if I just replace the H with 8 and the K with 1. So that's all I've done is just replace to the original formula with my H and my K. Now I'm going to use this ordered pair to find my A value. So what I'm going to do is I'm going to use this as my X and my Y. So I'm going to replace the Y with a 13, and I'm going to replace the X with a 10, and then I'm just going to keep the rest of the equation the same. And now from here, I can calculate what this value is. But you do have to be very careful that you do your order of operations correct. So we need to make sure we do our parentheses first. So 10 minus 8 is 2. 2 squared is 4. And we typically write that in front of the letter because this is A times. So now we kind of switch those around due to the commutative property. Now we're going to subtract 1. So let me just kind of move over here. So I get 12 is equal to 4A. And now I'm going to divide by 4. And I get my A to be 3. So notice if I were to go back to my drawing here, do you see how the A value is positive, which I kind of already knew, but it's a 3, which means that this is a bit of a vertical stretch. Now, I would not have known that unless I probably had got out graph paper and graphed this very, very accurately. So in this way, we don't need graph paper. We can just do our calculation. So my final step here is I need to take this 3 and put it right back in place of this A. So like if I was writing in pencil, I could just put the 3 right there. So see how I replaced it? But let me just rewrite it for you. 3x minus 8 squared plus 1. So this would be my final equation for this piece, okay? So if you want to pause it here, why don't you go ahead and give number 2 a try? All right, hopefully you've paused it and you replaced your H and your K. Now just be careful here, it's minus a negative 4, so you just have to zip zap, and then we do plus 6. So I've just replaced my 2 letters, and now I'm going to plug this in for my X and my Y. And it's okay that X is 0, it actually makes it easier. So we plug in the negative 26, and then we're going to plug in the 0 for the X. And now 0 plus 4, that's easy. That's just 4. What's 4 squared? 16. So we have negative 26, 16a plus 6. Again, do you notice how I put the number in front? Now, solving equations, I have to move the 6 first. I cannot put those together. So you want to move the 6. So you're going to get negative 32 is equal to 16a. And then we're going to divide off the 16. So we have negative 32 divided by 16, which is what? Negative 2. So look at that. It must open down. Again, let me just grab my scrap piece of paper here, and I'll kind of just do a rough sketch. So negative 4, 6, that would be my vertex. 0, negative 26. Whoa, that would be like way down here. So my parabola must look something like that. But you notice how it's going down. Hey, my A value is negative, so I know that this is correct. So let's just quick rewrite this. We've got our A value, whoops, sorry, I have a pen here. I have my A value of negative 2, and then I just recopy this part. So I have x plus 4 squared plus 6. This is my H and my K. And that's my final. Now, you're welcome to try number 3, and I can go through that one as well, but I thought it might actually be kind of nice to go back and look at one like number 2, okay? So I would like to actually do this one in its place. So if you don't mind, I'm going to make kind of an adjustment here. So we're going to skip this one, and we're going to use this one. Sometimes that happens. Sometimes you adjust, and that's okay. Okay, so how do we do it like this? Now, we already know where the vertex is. We know that the vertex is that turning point. Remember, down, down, up. Also, look at the symmetry. So we know that this is our vertex right here. This must be our H and our K. But how do we find the A value? So let me plug that in. X minus the X value, which is a negative 1, and then the K is 0. So I actually could probably drop that in a minute, okay? All right, how do I find the A? I have 4, 1, 2, 3, 4 different options. Class, you get to pick. You can pick any one of these 4 points you want to calculate the A value, and I promise you, you will get the same answer. So I bet many of you might pick 0, 1. So if you want to try 0, 1, give it a try. I'm going to pick this one because maybe it's the hardest one and I just want to try it. So I'm going to plug in the 4 for Y, the negative 3 for X. Now I'm not going to write that plus 0 because it's not going to do anything. So negative 3 plus 1 would be negative 2. Negative 2 squared is 4. I divide off the 4, and I get A to be 1. If you tried one of these other ones, you probably got the same answer. All right, now all we got to do is plug this back in. So we have y equals, now if you don't want to put the 1, you don't have to. It's considered understood. So 1 and then x plus 1 quantity squared, and then we don't really need the plus 0. So this right here would be my answer to number 2 from yesterday's lesson. Okay? So that's definitely kind of an interesting and unique way, is you get to pick any one of these options. And so the same thing would be true with this one down here, number 4. You have your H and your K, and then you would get to pick any one of these to choose as your X and your Y. I'm assuming many of you would probably pick this one just because it would be less calculations, but that's really up to you, okay? And so if you want to give those a try, those are great ones to practice. But I'd like to show you the other form, and that's called intercept form. So intercept form, if I can squeeze it in here, was x minus p and x minus q. Okay, that's intercept form. Now, we did not have any examples of intercept form in yesterday. And yesterday you only had these two quadratics, and they both gave you the vertex. So intercept form is not necessarily as common, but it still does exist. So I want you to make sure you understand how to go through it, because you don't know what they're going to throw at you in another math class. So number 4 says it passes through these 3 points. So let's look at my rough sketch of a graph here again. Again, it's not perfect, but it's very helpful. -3, 0, 7, 0, 6, -36 is way down there. Wait a minute. These must be where it goes through. But does that look like the vertex? Look at my drawing. No, that's probably not the vertex. All we know is it's a point. For all we know, the vertex could be down here, and then it goes up. So we cannot use this as a vertex. It's just a point on the graph. Okay? So what we're going to do is we're going to use our P and our Q, and then we're going to use this point. So let's go through this. This is our P and this is our Q. It really doesn't matter which one's which. And we're going to plug it into our formula. So x minus the P, x minus the Q. So there's our intercepts. And we're going to use this as our x and our y. So if we plug those in, that's going to be a -36. Now every time I see the x, I have to replace it with a 6. So 6, and then I see the x again. So see how I just replaced it twice. Now, if you want to grab a calculator, you can. It's not too bad. But if you type this in, 6 plus 3, 6 minus 7, and you're just multiplying them together, notice I get -9. So normally we write that in front of the letter. And now we're going to divide this off. And so we get +4. So that means it's opening up with a vertical stretch of 4. Remember my graph here? We knew it was opening up, but we had no idea where the vertex is. This still is not giving us the vertex, but it is giving us the vertical stretch. So we're going to put the 4 in place of the A, and then we're just going to go ahead and recopy this. X plus 3, x minus 7. Now, what would you do if somebody asked you for the vertex? If somebody said to you, give me that vertex. You're like, I have the intercepts. I don't know the vertex. You should be remembering the formula. It's P plus Q divided by 2. Remember, that gives you the first number. So that's 4 divided by 2, and then you plug it back in. So then we would take our calculator, and we would say 2 plus 3, 2 minus 7, and we would get, whoa, -100. That's the vertex. Okay? So you can get all of the pieces of information that you need. It's just sometimes you have to go back and use other parts of our formulas that we've had, okay? Why don't you pause it here and try number 5 on your own? All right, hopefully you tried number 5. So this is our P and our Q, and then this is just going to be a point on the graph. Now notice this is actually the y-intercept, but that's okay. We're just going to use it as a point. So we don't know which way this is opening. We have x minus a -4, x minus our q. And again, this is going to be our x and our y. So we're going to plug the -4. And then when I see the x, I have to put a 0. So 0. And then when I see the x, I have to put 0 again. And now I work this out. So 4 times -2. So 4 times -2 would be -8. And now I divide this off. Remember, you always have to divide the number in front of the variable. So divide it off and you get 1/2. Hey, that just means that this opens up and it's a vertical shrink, which means it's a little wider. But don't let the fraction bother you. That's just, hey, telling you it's wider. So we're going to plug that in. We have our vertical shrink, and now we still have our intercepts. So we have our x plus 4 and our x minus 2. And so this is our equation. This equation, remember, does not give you the vertex. If you want the vertex, you have to run the formula. So you have to go P plus Q, which you have right up there, P plus Q, divided by 2. So that would be -2 divided by 2, which would be -1. And then we would need to plug that back in to our equation. So we would do -1 every time we see the x. Ooh, I don't have a lot of room here. Let me write it down here. -1 comma -4.5. That would be our vertex. So again, you could ask me all kinds of questions. What's the axis of symmetry? What's the domain? What's the range? All that kind of stuff. Because remember, axis of symmetry, first number. Domain, all real numbers. Range, y. Notice it's positive, so the range would be y is greater than, because it's opening up like that. So they could ask you all kinds of questions and you can still pull your information, okay? Now there is one other example on here, but I'm going to go ahead and skip it just because I don't want this video to be really long and we still have a number 7 that I want to talk about. And from our lesson on 8.6, we never had an example where they gave you intercept form. Both of these were vertex form. So I don't think we probably need to practice another one of these. So we're just going to skip this one, okay? Now, number 7 down here, it says pick one problem from above and write it in standard form. So if I was there with you, I would ask you, like, which one do you want me to pick? 1, 2, 4, 5, which one do you want me to pick? So how about I'll pick number 4. In number 4, here's my equation. Okay, so I'm just going to recopy it. You have to put this in standard. Do you remember what standard is? Standard is the one that's ax squared plus bx plus c. So what you have to do is you have to get rid of these parentheses. So you essentially have to FOIL this out. Now you have 3 parts here. You have a monomial and 2 binomials. You can multiply them together however you want. Typically, I usually ignore this and I would FOIL. So I would do my first, outer, inner, last. I would FOIL it out. I'd put my middle 2 terms together. So there's my FOIL. And then now I would just multiply everything by 4. Let me grab another sheet of paper here. So if I keep this going, I'd have y equals, and then if I distribute, so 4 times x squared, 4 times negative 4, 4 times negative 21, which would be 84. So now I have just changed this into standard. So I went from intercept form into standard. Does that make sense? Okay. So how about I'll try one more. How about let's try a vertex form. So I just showed you how to get it out of intercept form. Let's pick a vertex. So if we go up here, notice we have 3 of them to choose from. So again, I wish I was there with you and could ask you to pick. Maybe this one looks a little harder, number 2. Okay, so let's do that. Let's take number 2, which is in vertex form, and let's go to standard. So that's what we're going to do. So let me just recopy this down. And basically, I need to get rid of these parentheses, but I got to be very careful in how I'm going to do this. I have to do my parentheses and exponents first. Remember what this squared means. You cannot distribute this square. It means that your parentheses are repeated. It's like that. So probably the first thing I would do is I would ignore everything and I would just FOIL those 2 out. So if I FOIL these out, I would do first, outer, inner, last. That's simply FOILing. If I put my middle 2 terms together, there's my trinomial. Now I still have this minus 2 and it's multiplied by, and I still have this plus 6 in the back. So the only thing I've done is just simply FOILed these out. I'm going to go ahead, still following my order of operations. I'm going to distribute. So I'm going to take this negative 2 times the parentheses, and it stops at the end so it doesn't affect the 6. And now I just have to add the 6 on. So that would be what? A minus 26, 32 minus 6. I have to think about that for a minute. Yeah, 26, that was right. So now I just went from vertex. Notice here's my H and my K. And then notice my A value. I went from vertex and I changed it into standard. Now, one last thing, if you want to really know if you're doing this right, is check the vertex. Check your vertex. Remember, it's opposite B over 2A. So if we do opposite B over 2 times A, that's 16 divided by negative 4, which is negative 4. And if we plug that back in, just typing it back in to this one right here, to my standard to check it. So I just, every time I saw the X, you see how I just replaced it? And I get a 6. Look at my vertex. Negative 4, 6. Negative 4, 6. So I know that my equation is correct. So technically, these two, even though they look drastically different, are the exact same graph. Okay, so again, we call this an extension lesson. There is no exit quiz, but there are some additional problems if you would like to practice them, because this is a skill that you will need in future math classes, so it is good for you to practice it. And that wraps up our chapter 8.